We know that in population, when we want to do some analysis, we take a sample and then we analyze the sample separately from the population, but we always assume that there is a normal distribution of a variable, for example height here, in the population. And based on this assumption, we want to know how close is the sample when we're checking the height as one of the variables is also distributed normal. Sometimes it's possible to correct the normality. For example, in this case, we have a distribution of height in our sample like this, which we don't know how close this one to the normal, and how should I correct this one. So we use it especially in parametric methods that we are using in the SPSS. And before that, for assessing the normality, we can do it by going to the analyze here in the top, and then in descriptive statistic, and use the command which is explore. And here we have the dependent list here, and we are going to assess, for example, the height, and then put it in the dependent list. And we need to label case here by the ID number. So this is just a formality to know that we are using all the cases here. And then we can go to the a statistic here, and be sure that we have the confidence interval for 95% here. We can choose the outliers to find out if we have some extreme cases, for example very short or very high, that will affect the total result. And then we can go to display and then continue here, and then we can go to we should be sure that in display section we use both at not just one of them. We can go to the plots, and then here we sure to use the histogram. We can just take this one out, and normality plots with tests. Also we are going to choose this one, and then continue to next one, and then we can go to the options, and here we should choose exclude cases pairwise. So it just clicking on the continue, and then we can choose the OK, or we can choose the paste. This is a function that I can explain later, but when we use paste, actually we save all this procedure that we did right now. So if we want to do this one for another variable, we can use the option. Now I use this syntax, it's called syntax. When you use the paste, then you will see that it start if we just this one, as you see, it will start a new window, and here we have the data set and also all the things that we choose separately. The only thing that if we want to do with something else, we can just copy and paste all these lines that we have here from dataset, and with a right click over this we can copy this one, and then we can go 2 or 3 lines later and comment, and we can paste it by Command C, or with right click and paste here. As you see, we have exactly the same. The only thing that we need to do now is just choose the height and write the name of another variable that we want to check, so we don't need to go through the whole things, and we can later save this syntax and use it several times. And now if we want to do to execute one of these orders to SPSS, then we can choose just highlight the whole lines and then click on this green one here, run selection, and then it will be exactly like the same way that we if we just click on the OK results here in the output window. And then the first one, as you see here, is a table labeled descriptive, the first one we have here. And here it's all the data provided with descriptive statistics and other information concerning the height that we checked here. And if we specify group variable, here we can see we have a mean here. What we are looking for here is this 5% trimmed mean, as you see. We should compare this one, 5% trimmed mean, with the mean that we have here. 5% trimmed mean means the SPSS cut the 5% from the both sides and calculate the mean again. So if there were some extreme numbers in each side for the height, then we removed it by 5% trim, and then we check the mean again. So here is the mean. Here the mean is 172.82, and the 5% trim is 172.63, which are very close to each other. So it means that we don't have extreme values. To be sure about it, we can go to the next one here, extreme values, and we have 5 of the highest and 5 of the lowest, which was trimmed, but here just the values. And we have the case numbers, case number 3, and the ID number, so it's very easy to find it. We can go to SPSS and see this one, number 3, for example, belong to this one, which is the registration number is 1406, and here we also have number 3, 1406, as you see, and the height is 196. But as you see, it's in a range with the others. It's not suddenly 210, for example. So we don't need to remove any outliers to have a better closest mean to the trim mean, to the real mean. And then this part, we have this test of normality, that it gives the result of the test which called Kolmogorov-Smirnov statistic here. And this statistic have this part which is show is it significant or not, and it's significant. If it's the value is around the number, it's 0.05. A little bit lower, that we have a borderline normality here, and we can say this is a little bit violation of the assumption of normality in this sample that we have compared to the normal. And we can see the actual distribution here. This is the frequency. For example, here is 25, so it's about 24 of our cases. They are 170 to 172, as you see here. And then up to the other numbers. So as in this histogram, we just see the normal. And also we have the mean, we have the standard deviation, and we have the number of cases, 157, as you remember. But this one, the normal QQ plot of höjde, or height in centimeter, and we had two parts. It was the expected normal, which is show this line, this is a straight line, and the observed value, which is all these dots here, and as you see they are very close to each other, and the normality here is we can say that this is reasonably a straight line and suggests a normal distribution here. We have another plot here. As you see, it's called Detrended normal QQ plots, and this is a little bit more difficult maybe to interpret, but if you have a clustration of the dots next to this zero line, then we can think that we have violation of normality here. We don't have much here, and this one also shows the normality is good, so we actually don't need to interpret this one. The last one is a box plot of distribution of the height, and as you see, you know about it, this is the mean, and this is the 50% of the cases between these numbers, which is 168 almost to 179, 50% of them. And we have also the mean here, which we had it up here, 172.82, almost 173. So this line is 173, as you see. And then the other 50%, we can see that the part is here, 25% and 25% here, so it cover all the cases.